Hey, what's happening everybody? Welcome back to the Kohi game engine series. Today we're going to knock out the platform layer, and we're going to start on that right now. So before we jump into the video, I would like to take a second and thank the channel's partners, Eearslya and Wensheng. The partners are the highest tier of membership on the channel, so I thank you guys for your support. I'd also like to take a quick moment and thank everybody under the supporters section. All of you guys that are listed here on the screen, thank you very much for your support. It's greatly appreciated. If you're interested in supporting the channel, one way that you can do that is you can go ahead and click the join button below this video. If you'd like more information on memberships, I'll go ahead and post a link in the description below, as well as a card in the upper corner of the screen. With that stuff out of the way, let's go ahead and jump into it. So before we jump into the code, I wanted to take a quick second and talk about what a platform layer is and how we are going to set it up in Kohi. So first off, what is the platform layer? Well, in our case, we're going to loosely define the platform as an OS or type of device. So this might mean Windows or Linux. Mac, for example, it could mean Android, or it could even mean a game console like Xbox or PlayStation, Switch, something like that. And so our platform layer is going to abstract the platform-specific code that each of these things requires from the rest of the engine. So the engine doesn't have to care whether it's running on Windows or whether it's running on Mac, Linux, PlayStation, whatever. And so we're going to achieve this by piping all platform requests through a single platform interface, is what we're going to call it. And you guys will see what I mean by that here in a second. One more note that I want to make is windowing is one of the things that we're actually going to be abstracting away. Now, desktop operating systems, for example, have the concept of windows to allow you to switch applications and things like that, but that is pretty specific to desktop operating systems themselves. So Windows, Mac, and Linux have this, but if you think about it on a Android device or Xbox and PlayStation, you don't have the concept of a window. You simply just switch the entire screen. And so there's not really that concept that exists on some of these platforms. And so what we're going to do is the concept of windowing itself is not going to be a concept that we are going to embrace in this engine. And if you think about it, windowing isn't really something the engine ever needs to know about. All it needs to know about is how big is the surface I'm going to be drawing to. It doesn't care where it is on the screen. It doesn't care that it's a window even. It doesn't care whether it's full screen or not. At the end of the day, all it really cares about is how big it needs to draw to somewhere on the screen. And so we're going to do our best to abstract all of that away. So what is our platform layer going to look like? Well, we're going to have a platform interface, which I mentioned before. That's going to be a platform.h file. This will not contain any platform code itself. However, it will contain function signatures to call into platform code. And so behind this, our implementation of this interface, if you will, we'll have various C files, right? So we'll have one for Win32, we'll have one for Linux, we'll have one for Mac, and then maybe at some point we'll have like one for Xbox or PlayStation and one for mobile operating systems, things of that nature, right? And the way that this will work is only one of these C files will actually be compiled for a particular platform at a time, and all the others will be disabled. And so we're going to define our interface in the H file, and then whichever platform we're compiling for will determine which of these implementations we use. And so all of these files essentially are going to point to platform.h. The rest of the engine will make its calls into platform.h, and our platform-specific implementation then no longer matters to the rest of the engine. With that in mind, I want to create a new folder under source, and I'm going to call this platform. And under that, I'm going to create platform.h. And of course, we're going to have our standard pragma once with our defines h to get our types. One thing you may be asking is, any of you that have programmed against Windows or Linux before, or any platform-specific code will know that there are certain aspects of state that have to be maintained, whether it's a handle to a window or something of those lines. And so you might be wondering how we're actually going to maintain that and be able to communicate with the rest of the application in a decoupled way. Well, the answer to that is something that I'm going to refer to as the platform state. So it's a simple structure here with a void pointer to internal state, right? So this is typeless, and the type of this will be determined on the particular implementation in the C file. So that is how we're going to keep all of this opaque to the rest of the engine, is we're going to use a technique like this. And you're actually going to see me use this technique in several places through the engine. So I know some of you guys were asking about how we were going to go about doing that. This is the answer to that. Okay, so the very first function that we're going to add here is something called platform startup. Now it takes a platform state, which is one of these, right? So something will have to create this structure and pass it in, and then this will actually wind up filling that out. Now you'll note here that I have application name is something that's in here, and then we have an XY and a width and a height. So these things are determined by the user application. So if you're running on a desktop, for example, we can say the starting window size. Whereas if you're running on a platform like, I don't know, PlayStation or something like that, you'll know this in advance as to what that's for. The application name is pretty much only going to be used for windowed operating systems, but we want to be able to supply that anyways so that it can be used to title the title bar of whatever window we're using. But there is a chance that this may not actually be used in all platforms. So I tried to keep this structure as minimal as possible. So that is our platform startup. It's the very first thing that we'll have to call. So as you may have guessed, since we have a startup, we also need a shutdown, and that is simply going to take a pointer to our platform state. The next call that we're going to have is something called platform pump messages. And this is something that needs to be done continuously throughout the loop of the application. And we're actually going to see some examples of this once we actually start on the Windows portion of it, as well as the Linux portion of it. And so because of that, I will come back and actually explain that later. Okay, so the next thing that can be a little bit platform specific is dealing with memory. And so I'm actually going to create some functions here to allow us to have platform specific ways of dealing with memory. One for allocation, one for free. So you have your equivalent of malloc and free. Something to zero out memory, something to copy blocks of memory, and then something to set blocks of memory. And this is going to wind up being pretty simple, at least in the beginning, but eventually we're going to be writing custom allocators and stuff that works with this directly, as well as things like aligned memory and whatnot. So you'll notice in here that there's an aligned. I'm not going to talk about aligned memory just yet, but in terms of setting up the interface, that is something that we're going to have to do on some platforms. So that is something that I wanted to include right from the get-go. Okay, so the next thing is, and some of you had alluded to this in the comments to the logging video, that there are various ways that we can write out colored text to the command prompt or whatever it is, terminal that we're using. And so this is a way that's going to allow us to do that in a platform agnostic way. And so this U8 color here is actually going to be tied to our log level. And you'll see once we actually get into the specific platform code, there's going to be different implementations of this per platform. So we have a platform console write, which is going to be responsible for writing to whatever console that platform provides, if it provides one at all. And then we also have a separate one for errors in case we want to separate that to a different stream. One more thing that the platform layers is responsible for is getting time. And so we have here a way to get the absolute time as a float 64. The way that you obtain the current time, or the clock, or wall clock time, if you want to call it that, is different per platform. And so this just gives us a agnostic way to deal with that so that we can make that translation under the hood. And again, the engine doesn't have to worry about it. Last but not least, we also need a way to sleep. And this is not something we're going to be using at least right away, but it is something I wanted to include because it is something we're going to need once we go to stabilize our frame rates. So we need a way to be able to sleep for a certain amount of milliseconds, and this will provide that. Okay, so this is pretty much the entirety of our platform state for right now. We may expand on this as the engine grows, but for right now, this is pretty much it. There's not a whole lot to it. However, as you'll see here in a moment, when we actually go to fill this out behind the scenes, there is a lot that actually happens under the hood, right? So the whole goal of this is to simplify things for the rest of the application and abstract away the complexities of the operating system. And that is exactly what this interface is going to do. So I'm going to go ahead and save this because we're done with this for right now. And under platform, I'm going to create a new file. And I'm going to call that platform win32.c. Since we're starting on Windows first, that makes sense to me to go ahead and just knock the windows out right now. So the very first thing we're going to do is include platform.h, because obviously we are going to be implementing this interface. And the next thing that we're going to want to do is we're going to want to check to see if we are actually on the Windows platform. And so we are basically going to block the entire implementation of this out within this if check. So if we're on Linux, this whole thing is going to be disabled, or that is how we are going to implement our platform specific code, is basically by just shutting off the implementation for all platforms except the one we are currently compiling on. And that will give us what we need in terms of functionality. Okay. So in terms of the files that we're going to have to include, we need a couple of Windows specific files, right? So we need windows.h and we need another one called Windows X. And I will get into why we need that. I put a note here for parameter input extraction. We'll get into this a little bit later, but these are the operating system specific includes that we need for the Win32 platform. All right, so the very first thing that I want to do is within this, I want to put together the implementation of our platform startup. Right, let me space this out a little bit different. There we go. Okay, and so in here, this is where we're actually going to start filling out these functions, right? So the first one is startup. So as I mentioned before, one of the things that we have to do right off the bat is to create our internal state, right? And so since we have an internal state that we need to create, we need to declare a type for that, right? Because if you recall back here, our internal state is just a void pointer, right? So the rest of the application doesn't know what it is. So in here, right after our includes, we need to create a structure, and we're going to call this internal state, okay? And in this, we are going to, for right now, include two things. So we have an H instance, which is basically a handle to the instance of the application. This is a Windows specific thing. And then a window handle, which is an hwind. And that is what we're going to use to keep a handle to the window that we're actually going to be opening. And again, the rest of the application is not going to know about the window, so it's okay to create it in our internal state here. So the first thing that we're going to do is, in order to use our void pointer, we are going to call malloc, and we are going to create the internal state, the size of the internal state structure that we have here, right? So we're going to go ahead and allocate the memory for that. And then we're going to go ahead and cold cast that to our known type, and we're just going to call it state, right? And this is how we're going to work in the rest of the platform layer, and actually several places throughout the system where we deal with void pointer types like this, or opaque types as I'll call them. This is how we're going to handle that. Now that we have the state, we can actually access these internal objects because we know what they are without having to sort of cast it inline everywhere, because that gets messy. Okay, so the first thing we're going to do is we are going to save the current module handle to H instance. So the module handle, when you pass 0 like this, is basically saying, give me a handle to the application that's currently executing this code. And so we're just going to save that off. And now is when we actually get into the sort of meat and potatoes of the windowing code. Windowing in Windows is a little bit strange. It's a little bit of an antiquated API, and we'll see some examples of why that is, or at least we'll see some examples of how that is. But the Windows API basically requires you to fill out a structure called a window class. And the window class contains some basic information that we need to create a window. And so we'll have to create a window class, and then we'll do what's called registering the window class. And if at that point it succeeds, then we can go ahead and fill out a little bit more information to go ahead and create our window. And then of course we'll want to open our window so that we can actually see something on the screen. So we're actually going to do all of that within platform startup. And so to get started with this, we need to set up our window class. So I'm not going to walk through a lot of detail on how to actually do this. However, I do want to point out that the Microsoft documentation is available on all of these structures if you guys are curious as to what these individual properties do. I'm not going to go into depth on coding in Windows against the Windows API, because the whole point of this is to get away from this stuff as quickly as I possibly can. So I'm not going to sort of open this up, but just know that you can actually search for, Win class A or register class A, etc., and be able to pull up the MSDN documentation on all those various things. So the very first thing we do is we go ahead and zero out the memory, right? So we want our window class to have a default of everything as zeros. And then as far as our style, we can pass a bunch of flags here, but the one that I'm interested in is I want to capture double clicks because we may need that at some point. And if you don't explicitly actually provide that, it may not actually do it. This next thing is LPN FN windproc. So this is a pointer to the window procedure. So the window procedure is basically what handles events within the system. So Windows is a very event-based operating system, and so there are going to be various events that need to be handled and popped up over time that we need to handle. And this is basically the method that's going to do that. Now you'll notice that we have not actually declared this yet. So we'll come back to that in just a second. One other thing of note, we're pointing to our H instance that we got up here. And then also I've gone ahead and created a icon. This is something that we could change out later once we get to the point where we actually want to display some sort of icon. We don't really have an icon yet to speak of for this, but this is how we would go about doing that. And then we basically tell the operating system here that we're going to manage the cursor on our own. And so that is what that is doing. And then this last thing is kind of important. This is what the class name is. So the name of the class that we are registering, this is the string representation for that. So when we actually go to create the window, we are going to need to know what this string is and use it accordingly. As I mentioned before, you create your window class, and then the next thing you have to do is register it. And so register class A takes in our window class that we've filled out. And this actually returns essentially what is a Boolean. So if it returns 0, then we know that there's some sort of registration failure. We may have filled out something incorrectly here, something that's invalid. And so this message box A is actually a Windows specific way to say, hey, pop up a message box that says that the window registration failed, throw in an error, and then put in an OK button and so forth. And then we're actually going to return false, because when we call this, if we return false, then we know the platform did not start up correctly and we can't continue with the application. So this is one of the first ways that we are going to check to see that things are actually put together properly and boot out of the application if they're not. Okay, so before I move on to window creation, I probably should go ahead and set up this window procedure. So I'm going to forward declare this at the top, and this is what the function signature looks like, right? So again, this is a whole bunch of Windows specific mumbo jumbo. But basically what we have here is our Win32 process message, and it takes in a handle to a window, the message that is currently being processed or handled, and then a W param and an L param. And these are fields that mean different things depending on what message is actually coming through. And so we'll fill this out in a bit, but I just wanted to put this here so that the compiler knows that there's something coming. Cool. The next thing that we're going to do is create the window. With a Windows window, there are two sizes that we have to be concerned about. There's the size of the overall window itself, right, which is this outside rectangle with the border and all that stuff. So that is one rectangle that we have to worry about. And then we have what's known as the client area, which is everything sort of inside this area here. And this is the area that we're actually interested in. Let's say we want to create a window at 1280 by 720, right? So 1280 across by 720. That's actually the size that we want the client area to be, not the entire window. So we'll actually need to perform some calculation to say, hey, we want our client space to be this big. How big does the actual outer window need to be to accommodate that? What we're going to do is a couple of checks, right? So we're going to create some client spaces, which is actually what we're going to pass our X, Y, width, and height to. So this is defining our client area, and we're initially going to set our window area to those same things. We're just going to copy them over from the client, but we're actually going to be modifying these when we go to actually create the window. Some other things that I want to put in here is some information about window styling. And so if we actually look, in the MSDN documentation, there are all kinds of these window styles that we can use, right? So one of the first ones that I just searched for was overlapped, right? And this is basically saying the window is an overlapped window. Super useful stuff. An overlap window has a title bar and a border, same as WS tiled style. So if we look up WS tiled, oh, it says it's the exact same thing. Okay, well, I didn't say MSDN's documentation is always the greatest, but this is sometimes the kind of stuff that you get. So let's suffice it to say that I have looked into this, and these are the properties that we're going to be wanting to use, right? And so we are basically going to, I'll explain the important ones here anyway, which is minimize, or maximize box, minimize box, and thick frame. These sort of describe how the window looks and what individual buttons it may have. Okay, so now that we have that, we need to obtain the size of the border, right? And so what I mean by this is basically we're going to take a look at our window style that we've passed here, take the framing, title bar, all that stuff into account, as well as our window style here. And it's basically going to fill in the values of this border rectangle here with how large this actually is. And what we're looking for here is actually, this is going to be an adjustment rectangle. So this is essentially how different the client area is from the outer window. And so in this case, our border rectangle is actually going to be negative, right? Because this is saying that our client area is smaller than the window area, right? So this means that we'll actually have to push out the border X, Y, as well as the width and height by the adjustments that we got in here, right? And so if you look at this, you can kind of see how that works. Again, I'm not really going to go into depth on this because I don't really want to focus on Windows programming, but just know that basically this expands the outer rectangle of the window in order to accommodate the client size. Okay, so the next thing we're going to do is actually create the window. And to do that, we call create window XA. This is the extended styles for the window creation. And here you'll see our window class again that we had up here. So that is where that has to match. If that doesn't match, this will fail. Here we're also passing the application name. This will become the title bar. And then you'll see here we are actually passing the window style, the window X style, and then we're passing the X, Y, width, and height. So that's those adjusted numbers that we calculated here. That's really the only important bits of window creation. It's actually pretty straightforward stuff. If you guys are interested in more in-depth knowledge of that, feel free to look up these various functions on MSDN to have a better understanding of those. Okay, so the next thing that we need to do is, if we messed anything up along the way, then what's going to happen is this is going to return a null pointer. And so we need to check that to say, hey, if it's equal to 0, then something failed to create our window. We are going to log, which actually I need to add the logger here. So we'll include core logger. We're going to log that as a fatal message and return false because we can't continue the execution of the application if we don't have a window. However, if it is successful, then we're going to update our state objects hwind to hold the handle. So that is why I didn't just sort of assign it right away, because I want to be explicit about only assigning it if it was a success. Okay, so that is window creation. The next thing that we need to do is actually show it, because we've created it, but we haven't actually told the operating system that we need to show it. So showing the window isn't quite as simple as just calling show window, unfortunately. And the reason for this is because of the way that Windows manages input. And so when we show a window, if the window should accept input from like a mouse and keyboard, then we actually need to do what's called activating the window, which is automatically done if we pass this show. But if we don't want to accept input for some reason, maybe there's going to be a window that we create at some point that we don't want to, we would want to use specifically this show no activate. And so all we're simply doing here is basically choosing the correct flag as to whether or not we want to activate. I also put some notes in here that if we create the window and we go to show the window, and if it's initially minimized or maximized, some additional flags that we can use that are needed for those states. But we're not going to need that because we're not going to start off in a minimized or maximized state. We're just going to start in the standard mode for that. Okay, and then we call show window. We pass our window handle, and then of course our command flags that we're building here. All right, and that is almost it. So I'm going to put in a return true here, because if we get to this point, we have successfully initialized our platform and we're ready to go. There is one more thing that we're going to have to add here. I'll come back to that in a moment. Okay, so that knocks out our platform startup. So this is one of the biggest methods that we're going to have to implement. A lot of these are actually pretty small. Let's see. So shutdown is going to be the next one. So back in our C file, I'm going to make sure to stay above the end if and add on our platform shutdown. And our shutdown method, of course, is going to need our internal state. So we're going to cold cast to that. And the only thing that we have to do here is essentially, if we have the window, destroy it, right? So we'll check here to see if we have a window, then we'll call destroy window on it and then set it to 0. And that's it. That's all we're going to do for the shutdown of the platform for right now. Nice and simple. Okay, so the next one is going to be this pump messages guy. So this pump messages, just to give you a some form of reference here, this is actually going to be called within our main application loop. And I'll touch more on that once we actually get to that point. But our application loop is going to call this once every single loop. Okay, so we have our platform pump messages, which I'm going to fill out now. So we'll turn that into a function. And this is actually a shockingly simple method, right? There's only a couple things that we have to do here. So the way that the Windows messaging system works is it basically has a stack of messages, and we have to process those one at a time. And so strangely enough, it actually requires us to create a message object, which I believe is nothing but a simple structure. It's like an opaque type. And then this peak message A basically says, okay, if there's a message on the top of the message stack to be processed, fill out the message structure with it. And in this case, we want to actually remove it. Now you can peek without actually removing it from the stack, but if the message stack does not get cleared out, the window will become unresponsive. And so we have to constantly keep that cleared out. And so you'll notice here that we have this in a while loop that basically says just keep peeking messages until this returns essentially false. So when the message queue is empty, it will actually return false. And we're going to empty the message queue via this PM remove, right? So every time we call this, we're going to be popping a message off the top of that stack. It's going to be populated in here. We'll do some processing on it, and then we'll move on to the next one. So this is not our main game loop. This is sort of a secondary message processing loop that has to happen within the platform layer. And it's sort of specific to the way that Windows works. So again, I don't want to expose our application to that. This should be totally handled at the platform layer. So every time we grab a message off the queue, we need to perform translation on it and then dispatch the message. The dispatch message is actually what makes it fire off according to whatever method is defined here. So in this case, it's our Win32 process message, which we've not set up yet. But basically that dispatch message makes it actually call this method. So we're going to be filling that out in a little bit. I'll come back to that, but that's basically the way this loop works. And then once that has completed, it returns true. All right. So the next thing that we need to do is we need to fill out all of these guys, these platform allocate, free, zero memory, copy memory. Now, at least in the beginning, the way that we're going to do this is we are simply going to call methods that are in the standard library. So we're actually going to need to include standard library. And for now, we are just going to return malloc size, right? And note that this is very temporary, right? Because we're not making use of this alignment, and that is something we're going to cover. but it's sort of outside the scope of what I want to cover in this video. So for now, we're just going to use plain old malloc, but we are going to be changing this to something a little bit more robust in the very near future. So the next one is our platform free. And as you may have guessed, that's just going to call free. Okay. So the same is actually going to be true for our zero memory, our copy memory, and our set memory. Although if you are familiar with C, you know that there's no zero memory. So this is actually a convenience method that we're setting up. And basically all we're doing is we're calling memset to set the entire block of memory to all zeros. So this is how we're going to zero out our memory, right? And this keeps us from just having to call essentially this platform set memory and pass zero every single time. We can just say, you know what, we want to zero this block of memory, and then this just handles it. Copy memory just calls memory copy under the hood, and then memset, of course, is called by platform set memory. So we do still have this if we need to do it, but zero memory is probably the one we're going to wind up using more often. So that is those. So the next two we're going to handle are these platform console writes. So let's go ahead and get these in here. And if you recall before, I said that we have this color here, and this is where we're actually going to color our console output. More often than not, console output is actually done via a printf, so something like this. But for Windows, we actually have something that's a little bit more powerful for that than that we actually want to reference. So I'm not actually going to use printf for Windows. We're going to use something that is Windows specific, which is called write console A. And it basically allows us to pick which stream we want to output to. The standard output handle is basically the same as saying, you know, cout in C++. Or something like that. It's the standard output stream. It does require us to pass a U64 as to the length of the actual string, right? So we're actually taking the string length there, and then we're also taking a long pointer to a D word, which is the number of bytes written, right? That is actually passed here. So our write console A is actually what we're going to be using for that. However, where the power of this comes in is we also have something called output debug string A. And this is a totally separate output stream that only Windows has as far as I'm aware. And what this actually allows is in the terminal, this debug console here, it'll actually allow us to output text to here as well. So we're actually going to be outputting to both channels on Windows. So it just gives us a sort of extra way that we can kind of look at things. Okay, so that's the output to the debug console as well as the command prompt that is actually running. But we haven't handled this color section yet, right? So that is actually going to be handled by something that is called set console text attribute, right? And again, this is something that I've sort of figured out ahead of time. But basically what this does is it obtains, it takes a console handle, which we get the same as this one here. So basically returns a handle to our console window. And then it allows us to set an attribute on that. Now, there is a lot of documentation on this, which I'll briefly pull up. And it does say that this is outdated in the documentation. However, the default is to run with command prompt, right? So these things actually, what they're referring to here in this documentation only applies if you're using like PowerShell or the Windows terminal, which is not the default. So I'm actually going to completely ignore this for Windows and not do this. But basically what this allows us to do is we can set our attributes, our character attributes here. And if you see here, we have a lot of different values. So these individual numbers here coincide with the fatal, error, warn, info, debug, and trace levels. And this is a specific configuration of foreground and background colors that is sort of given an index as to what that combination is. And basically what we're doing here is we're saying, okay, look at the color that's passed in, match that up with one of these guys, and then from there, we want to go ahead and set the text attribute to that, which effectively changes the color for that line to the color combination defined in the index here. Now, I'm not going to go into how I found these because that was actually, it took quite a bit of digging. If you guys want to look into this, feel free to look it up, but just understand that these are appropriate color schemes for these individual messages. And we'll see those in action here in a little bit. Okay, so that is how we handle color. So the next thing that we have is our write error, which is exactly the same function with one major change. We change it to error handle, right? And so when we write out an error, we're basically writing to a different stream. And this is actually something that technically is supported in C++ through the C error instead of C out. That is the stream that this uses. It's a special stream for errors. So we're going to go ahead and leverage that as well. Other than that, everything else here is exactly the same. All right, so that covers colored console output. Now we have the bit about time. Let's go ahead and fill this out. So what this does is gets the absolute time since the application has actually been running. Now, there is some setup that we actually need to perform on this first before we can actually fill this out or use it. And so I'm actually going to go back to the top here. After our state here, I'm going to go ahead and paste in some static variable declarations. So the first thing that we need is a float64 clock frequency. This is basically a multiplier that we'll use to take the clock cycles that we'll be obtaining from the operating system and multiply them by that to get the actual time. And then we have something here called start time, which we're going to need. And this is basically the starting time of the application. Speaking of which, I did mention that we have one more thing that we need to do here, and that is what that is setting that start time. So to set that start time, we are going to paste in some code here. So we have a frequency that we've obtained from query performance frequency. This is what gives us our clock frequency for our specific processor, so that we know how fast the clock speeds actually are, relatively speaking. And then we're actually going to take that to get our floating point number, and we're going to say 1.0 divided by that frequency dot quad part. And what this basically is, this quad part is a 64-bit integer. And so we're basically converting that to a floating point by saying 1.0 divided by that. And then query performance counter essentially gives us a snapshot of the current time whenever this is called, right? So since this is when the application is starting, this is when we fill out start time. Okay? And then if we come back down here, so when we actually obtain the time, all we do is call query performance counter again, and then we take our quad part, which is our 64-bit number, that is our number of cycles since the application started, and we multiply that by our clock frequency to get the actual time, and then we return that. So this is how, at least on Windows, we're actually going to get our time in seconds stored as a 64-bit floating point number. So platform sleep, this is going to be another one of those things where we are actually not going to, we're not actually going to fill out a whole heck of a lot. Actually, we're not really going to do much of anything on this. We're basically just going to call Windows' sleep function and pass the milliseconds, right? And that's it for now. Linux handles this a little bit differently. Windows, it's actually nice and simple for once, but that's all there is to that. We've talked about this window procedure up here a couple of times, but we haven't actually filled it out yet. And so now is when we're going to do that. So I'm going to go all the way to the bottom because I don't want this huge function towards the top because it's a big boy. And I'm going to declare this down here, or define this down here rather. And we are going to take a look at some events and how we should actually handle those things, right? So the first thing we're going to do is we're going to switch on the message that comes in because there's a huge variety of messages. Okay, and the very first thing that we're going to want to look at, and again, this is without really wanting to get too deep into this, is erase background. So if you want to see what all messages are available, you can have a look at this exhaustive list here on MSDN's documentation. We're going to be looking at, things like WM destroy and some various sizing ones, things of that nature. So I'm not going to make you guys look at all of this. I'm actually going to explicitly put the ones in here that we need to care about, right? So this first one is erase background, which is basically notifying the OS that erasing the screen will be handled by the application. And that way the OS won't be trying to draw that in as we're trying to draw from Vulkan or OpenGL, DirectX, whatever. And this will prevent a flicker from occurring. And this return 1 is said explicitly by Microsoft's documentation, return 1 to tell the OS not to worry about it, that we'll handle it. So the next one is going to be WM close. And this is another one where we need to return something specific to let the OS know that we've handled it. In this case, we need to return 0. And there is an additional thing that we're going to want to do, which we don't have an event system yet, but we're eventually going to want to fire an event. Fire an event for the application to quit. Right, so we don't have the application layer yet, but I'm just putting a to-do in here to say, hey, when we get that and when we get our event system set up, we'll need to come back in here and hook that up. Okay, WM destroy was another one that we need to handle. So basically, when we try to destroy the window, we need to post this quit message, which post quit message actually, if I recall correctly, posts WM quit, right? And actually, in our case, we don't need to do anything specific with WM quit. So I'm going to let the default window procedure handle that, and we'll come back to that in a second. So the next one that we care about is one that's called WM size, and I'm actually going to wrap this one in braces because we're actually going to have to write out a little bit of code here. So we need to get the updated size of the window, right? So whenever we have this, we want to say, okay, this is basically telling us a resize has occurred, okay? And so we want to get that size. And then we want to eventually fire off a message. So I'm going to say to-do, fire an event for window resize, okay? And then that'll be handled by the renderer or whatnot. So I'm going to comment this out for now, but I just want to put that in place so that we remember to come back to it. So the next one that we're going to have to concern ourselves with is input. And remember I talked about activation. So this is where that comes into play. So this is going to be another one. These are the key up events and system key up events, and key down events and system key down events. And some of the buttons only work in key down, some of them only work in system key down. And so we're just going to handle them all up and down all together at once. So the first thing we'll do is we'll say, we'll check to see if it's an actual press or release by checking to see if the message was key down or system key down. And then we'll take that information and we'll fire off some events. So again, input processing, right? So I'm going to comment that out for now because it will not run. It will not compile if we have unused variables there. So we'll be handling input processing here, at least for the keyboard. And the next thing that we'll want to put in is mouse move. And as you may have guessed, we need to get a X and Y. And if you recall, up here at the top, I talked about parameter input extraction. And so if we look at our callback here, we have W param and L param. And so our X and Y coordinates are actually stored within those two parameters. Specifically in this case, it's actually L param. And so, whoops, not that one. So what we'll do here is we'll get our X and Y position by using these macros that Microsoft has provided to get the X and Y params out of the L param. And I believe it's the high end of the number is the X position, the lower end of the number is the Y position. I may have that backwards, but they basically pack the X and Y into a single integer and pass it that way. All right. I'm going to say to do input processing because we're going to come back to this. But I just want you guys to kind of get a feeling for some of the things that we have to map out here. One more thing that we'll need to do is we also want to be able to handle the mouse wheel. So we'll go ahead and scaffold something for that. And the mouse wheel is actually pretty straightforward. So in this case, since the X and Y are the movement of the mouse on the screen back and forth, up and down this way, we're actually going to consider the wheel delta, which is the mouse wheel going up and down. We're going to consider that the Z. And we're basically going to say if the delta, which is the change from the last time that the mouse was interacted with, is not 0, meaning something has happened, then we're basically going to flatten the input to a -1 or a 1. And what this means is Windows actually provides kind of strange values for the scrolling, and I think they do this because you could technically use it to adjust the sensitivity of the scroll wheel. But in our case, we only want to know if it's gone up or down. So we don't care if they have like a value of 120 or whatever, but it may eventually screw us up if we have different amounts coming in from different OSs. So we're going to flatten that to a range of -1 to 1. And so basically we're saying if the delta is less than 0, we're going to just say, all right, it's -1 now. And otherwise it's 1. And we don't have to worry about the 0 case, because the 0 case in this case, this won't be processed if this is anything. If this is 0, this won't actually happen. So it'll already be handled sort of by that case automatically. And then, as you probably already guessed, to do input processing. So I'm going to comment this out. So the next thing that we need to do is handle the messages for mouse buttons being up or down. And there are a total of 6 messages for this, at least in Windows, which is L button down, M button, which is middle button, that's the mouse wheel, so that's if you click the mouse wheel. And then you have R button down, which is the right button. And then you have the up states for those 3 things too. So let's go ahead and put a break there. All right. And so we're going to first detect if it's a press, similar to how we did the key, by saying if it's one of the down messages, we'll go ahead and set this to true. Otherwise it'll be false. And then we're going to go ahead and to do input processing here, because there's actually going to be some more logic that we need to add to this, but we are not at the point where we can actually handle that yet. So I just want to sort of scaffold that out for now. Okay, so for now, those are all the events that we want to handle. And I say handle with air quotes because we're not really doing much handling here at all yet. But I just wanted to give you guys an idea of some of the things that we need to handle at this level once we actually have some more things stood up. Okay, so after this switch, we've handled the event and we potentially get down here and we say, okay, well, what if we have one of these events that we have handled that doesn't necessarily have a return value, that doesn't have to boot out? What do we do next, right? Because this has to return something. Well, that is where we call our default window procedure. And this is one that Windows provides to us, which says anything that we're not handling here, go ahead and handle in the default manner that it would under normal circumstances, right? So you can think of all these things that we've added here as overrides. Okay, and so if we get to this point, we'll say, okay, just call the return, call the default window procedure, pass in everything to it that was passed in to us here, and then go ahead and return its value. And that is it as far as the platform goes, or at least for message processing for right now. So let me actually do one more thing. Let me go down here and just put a comment as to what that's for. So this is actually the Windows layer, at least as complete as it's going to be right now, right? So you can see all this stuff is not stuff that we want to have to worry about in the rest of our application. It'll be nice for us to be able to split out some of these things and translate some of the things into a platform agnostic type of data so that we can handle it in our application gracefully. Okay, so let's go ahead and build this real quick. Okay, so that looks good. And we'll go ahead and put in a temporary test. So we'll go to our main.c here. You know what? Actually, before I do that, I want to actually make an update to our logger because we actually put the the logic in there to handle our colored text, but we didn't actually hook it up. So let's actually do that really quickly. So I'm going to go here and put include platform H. Instead of this printf right here, we're actually going to resolve this to do. So let's get rid of that, get rid of this, and we'll also make use of our isError, and we will go ahead and snip in some logic here. So now we can say if it's an error, we want to go ahead and tell our platform layer to write to the console. And if it's not an error, then we want to just write normally. So write an error or write normally, and we'll pass the level along as well. A couple things that I wanted to point out as well. We are going to be enhancing some of this in here once we actually set up our string library, so we don't have to do all this. But there are some kind of hard-coded magic number things in here I want to get rid of. We have this isError is less than 2, which is not very great. So I'm actually going to use the log level for that to say if the log level is less than warning, which evaluates the 2, so it'll actually be the exact same thing. And then I'm actually going to set up a constant i32 message length equals 32,000. So that's a little bit more clear as to what that is. That way, if we change it in one spot, we don't have to change it in all the others. We can just change it here and be done with it. Okay, and again, like I said, we'll be coming back to this, but I just wanted to hook that up real quickly. And that should be it for now. So let's go ahead and build this. Let's just make sure it builds first. And it does, okay. So we'll hook this up in main. So for right now, I'm going to go ahead and include platform H. And I'm going to get rid of this assertion because I don't actually want to do that. I'm going to leave these here so that we can see our test text. So I'll say if platform startup, right? And our platform state, we actually need to create one of those. So let's go ahead and create that here. Pass the address of state. And application name, we'll just say test. And actually we'll say, let's be a little bit more creative with this, Kohi engine testbed. X we'll set to 100. Y we'll set to 100. Width we'll set to, remember this is the client width, so we'll need to set this to 1280. And the height we'll set to 720 or 720p. So if this is successful, then we will go ahead and call our platform pump messages, right? So what we'll need to do is we'll need to create a small loop. So in this case, I'll say while platform pump messages, and I'll pass the address of state. Okay, and basically, actually, you know what? I don't want to do that. I'm going to move this. We'll just say while true for now. That's fine. Okay. And then if we'll say if we do not have a successful return from that, that we'll go ahead and break the loop. One more thing. Our pump messages is always going to return. You know what? I'm just going to call this as is for now. Okay. So this is basically going to ignite our CPU and just continuously run and check messages, but that's fine. This is basically what our game loop is going to wind up looking like, and we'll have cancel flags and things like that in there, but for now, this is kind of the way that works. And then down here, we'll have platform shutdown, and we'll pass the address of the state. Okay, let's go ahead and build that. And looks like we have a linker error. Aha. That is because these are not exported. And these are not something I'm going to want to leave exported. Because really the user code should have no knowledge of this, but for now I'll export them. And we'll go ahead and run. And now, well, we can see that at least it's partially working. So we have our window here, right? It doesn't do anything, but at least we have our window. And we can see our console output here. Now, it does look like we are not actually outputting a new carriage return here, so I'll need to fix that. So let's go ahead and close this and go back to platform. Yeah, it looks like we're adding a new line here. I'm not sure why that's not. Oh, because this is passing out message instead of out message 2. Minor bug. Yes, we will be fixing this, just not right now. Okay, so now we have our window, and now we have our colored output. So this fatal message really sticks out like a sore thumb. That's why it's the only one that does not have a black background. But as you can see here, these are all appropriate colors, I think, for the individual level of logging that they're responsible for. So with that, that is pretty much all there is to the platform layer, at least the Windows platform layer. So that is where I'm going to leave this video. In the next video, we are actually going to implement the same thing, but for Linux. So we're going to jump over to Linux and go ahead and stand up the platform layer on that side. And then after that, we're going to set up an actual application to house our loop here, our game loop, so that we don't have to have all of this in user code. And technically that means the application will be in user code, and it really shouldn't be either, but it's a little bit better than having platform code in our user code. So anyway, with that, thank you guys for watching. If you like this video, please feel free to give it the old thumbs up. If you haven't already, consider subscribing. Go ahead and click that little notification bell there so that you get notified when new videos in this or other series drop. And I'll see you guys next time.